Welcome. I am Carol Hollingsworth, the JPS Vice President of Sales. Iggy Brigado, the JPS Senior Sales Engineer, will provide you with today's presentation. We really appreciate your joining us today. Today, Iggy will discuss the RSP-Z2 Dual Channel Gateway standalone voice logging. Iggy will discuss logging, archiving, and reviewing of radio, telephony, and push-to-talk over cellular voice communications using the RSP-Z2 Dual Channel Gateway in a simple standalone solution. This webcast will be a good voice logging primer that will eventually feature voice logging in future product briefing webcasts that feature larger distributed systems that incorporate multiple RSP-Z2 gateways, the Z2 controller, and the ACU-Z1 modular gateway. I have stated numerous times that the RSP-Z2 is the most application-rich product that JPS has ever introduced. JPS currently has several new applications for the RSP-Z2 that are being evaluated for proof of concept. The Z product line of products is continuing its popularity with increased applications and with increased sales. There are no boundaries for the Z products. There are many applications and small markets. We truly appreciate your being with us today. It's always a pleasure to do these and to hear from you. Now let's get to the real reason you're here today. Let me introduce Iggy Brigado. Iggy?
Okay, Carol. Hey, thanks again. Appreciate it. And I'd like to welcome everybody to the JPS Interoperability Solutions weekly product briefing webcast. I'm Iggy Brigado, Senior Sales Engineer, and we also have with us Carol Hollingsworth, our Vice President of Sales. And in this week's webcast, we're going to discuss the logging of voice communications using the RSP-Z2 Dual Channel Gateway in a standalone configuration. And these applications will be really most appropriate for small deployments where maybe only one or two communication resources need to be recorded. And up until the 1980s, the recording of telephone and radio communications was primarily performed using analog magnetic tape, where really just a handful of audio tracks can be archived on a single width of tape. And so the limitations of analog magnetic tape are obvious. And so the physical size and number of tape reels is one limitation, but the ability to search for specific time and date of snippets of audio is another, and the ability to capture and correlate metadata with archived voice was really not possible at that time. So Bell Labs began experimenting with vocoders in the early 90s, and the use of vocoders in the 90s helped revolutionize voice logging by the ability of quantizing and converting human speech into data, ones and zeros. So logging platforms can now archive not only voice communications of telephone, radio, and console transmissions, but can also collect and store metadata such as radio ID, emergency and man-down information, and even the timestamp, to name a few things. And the storage of digital data is much more space efficient than physical magnetic tapes. The addition of network protocols such as RTP or real-time transport protocol, as well as the signaling protocol such as SIP or session initiation protocol, has really simplified the delivery of voice communications over TCP/IP networks from remote sources, regardless of the distance from the communication source. A communication source can be provisioned to simply stream radio or telephony communications in the form of UDP, unicast RTP packets for voice loggers that are able to accept those RTP packets. Session Initiation Protocol, or SIP, is also used in voice logging applications. SIP is a signaling protocol that requires one endpoint, such as the communication source, to contact the recipient, which in this case is a voice logging appliance of some sort, to request the network connection to be made. And this is really analogous to a user using a digital SIP telephone to contact another user on another digital SIP telephone. And once the SIP connection is made, the RTP, or real-time transport protocol voice data, can begin streaming between these devices. And really the nice thing about many of our products, such as the RSP-Z2, is that those gateways can support both SIP and RTP. And most voice logging applications and appliances utilize one or both of those protocols to accept the digitized voice data from communication sources. So if you see us using a specific voice logging application, just remember the standard protocols that we use will allow you to use your existing or favorite voice logging platform of choice. So let's have a brief review of the RSP-Z2 Dual Channel Gateway. And as usual, you can always take a look at our previous webcast to learn more about the RSP-Z2 Gateway and the other products within the Z family of products. So the RSP-Z2 Gateway has a very diverse interface, which includes 4-wire interfaces that will support directly connected donor radios, and we'll see lots of examples of the use of donor radios. And so we have the ability to connect to remote assets using digital transport protocols such as JPS ROIP and the standards-based protocols that I mentioned earlier, which is SIP and RTP. And we can also support many mission-critical push-to-talk applications on the market using these digital transport protocols. And really a nice attribute of the gateway is its ability to operate autonomously, without the need to be supported by a server. And so all server-like functionality resides on board with the hardware. And this includes the control and configuration over a secure web browser. So this helps us reduce the number of single points of failures. But the gateway still has the ability to be introduced into a large distributed system that is controlled and managed by a Z2 controller or even an ACU-Z1 modular gateway. So the growth is really never an issue with a Z2 gateway. What makes the Z2 unique is that we can take any of the interfaces that we discussed above and backhaul their communications over various means depending on your requirements. And we can use dissimilar backhaul methods if needed. But for our voice logging applications, we're going to focus on the standards-based protocol, RTP, because it's easy to deploy, and many third-party appliances and services do support RTP. And like all the products in the Z family of gateways and controllers, we'll need to use our specific usernames and passwords to access the secure browser-based control and management platforms. And what's great about this is we can access these elements from anywhere on the network, and this makes troubleshooting and maintenance to be performed remotely. The RSP-Z2 Dual Channel Gateway has 3 native configurations, which gives us lots of interface and backhaul permutations. And remember, we are going to leverage RTP interfaces to stream voice communications through our voice logging destination. So in its most basic configuration, we're able to share communications between 2 different systems, which we designate this configuration as a cross-connect configuration. So in this example, we might have a VHF talk group and a P25 talk group. It really doesn't matter, as the gateway's digital signal processor at the interfaces support 4-wire devices. Those are purely agnostic. So we don't care about the transmit receive frequencies or how those radios are modulated. And we're also not concerned with the protocols, the encryption, or even the manufacture of those radio systems. And so, incidentally, we are currently still supporting nearly 400 different radio interface types. So this is an example of the RSP-Z2 user interface. So each talk group is represented by a resource icon where the user can access the digital signal processor for each of those interfaces. And so for all intents and purposes, those interfaces do not necessarily need to support LMR talk groups, but really can instead support digital protocols such as JPS ROIP and SIP and RTP, as well as push-to-talk over cellular systems. So we can provision one of the RSP-Z2 interfaces to support RTP, and this will allow the streaming of radio communications from the cross-connected talk group to the voice logging services. We can then define the channel interface from user interface. And so in this case, channel 2, the channel 2 interface will be provisioned as an RTP interface. The voice logger can then be configured to accept any RTP unicast stream from our many sources. And the communications from those sources can be differentiated by a discrete port value. So in this case, it'd be 8020. We can also access the RTP interface settings by right-clicking on the resource icon, and we can define the interface we would like to support, and in this case, it's going to be RTP, and we can make this selection from either the home page or from the settings page, as we can see here. And you can see how really it is so easy to move from one type of interface to another interface really simply by the click of a mouse. We can then designate the destination of the RTP stream, which obviously will be our voice logger. And that's it. We simply tell the interface where to deliver the RTP unicast audio stream. And if the RSP-Z2 will be streaming over the internet, the unicast stream will be able to access the destination without the need for a public static IP address at the gateway, which means it doesn't need a firewall for port pouring. It's perfect for facilities where static public IP addresses or the access to a network firewall is not available. Okay, so let's take a look at another native configuration of the RSP-Z2 Dual Channel Gateway, and that would be the cross connect with a single digital backhaul. And you've probably heard me say this many times before, but this is probably one of the most versatile RSP-Z2 configurations. And as you can see, we have maintained the interoperable cross connection with the two disparate LMR talk groups. And with this configuration, we're able to backhaul all transmit and receive communications of both talk groups over a single RTP backhaul link, which we can associate to our record channel on our voice logger. And remember, this is one-way unicast RTP stream where the source is the interoperability domain, which are the two radio talk groups at the top, and the destination is the voice logging recorder represented by the RTP resource icon at the bottom of the user interface. So we're capturing both transmit and receive audio communications from both talk groups simultaneously. So when the VHF subscriber unit in blue at the left is transmitting from the field, channel 1 interface of the RSP-Z2 will be in a core state because of the attached donor radio, and core is indicated in green. And then the voice communications is delivered to both channel 2 of the RSP-Z2 gateway as well as the voice logger at the same time as indicated by the red PTT indicators. And because our two channel interfaces do not necessarily have to support LMR talk groups, we can assign a digital transport protocol to one of those channel interfaces instead, such as a JPS ROIP protocol to support maybe a push-to-talk over cellular talk group. So depending upon the POC provider, you can use either JPS ROIP or RTP as your transport method of choice. And remember, that interface can support JPS ROIP, SIP, or RTP. And remember, when channel 1 or channel 2 is receiving communications from their environments, that communications will be streamed over the RTP link to the voice logger and also to the push-to-talk over cellular clients on their smartphones simultaneously. The third configuration of the RSP-Z2 is the independent pass-through configuration where the two channels are completely segregated. This means there is no localized interoperability taking place between the two talk groups, but instead, each channel can be backhauled independently using transport protocols such as, again, JPS ROIP, JPS bridge channels, SIP, RTP, as well as push-to-talk over cellular applications. And so, for example, this 800 megahertz P25 communications can be backhauled remote ACU-2000 gateway using JPS ROIP protocol. And VHF conventional communications can be separately sent using RTP to the assigned voice logging channel. So you can see two backhaul resource icons at the bottom supporting JPS ROIP and RTP respectively. And so we can have the VHF conventional backhauled over an RTP link and the 800 megahertz talk group over a JPS ROIP link, two completely different digital transport protocols. Alternatively, we can direct each talk group to stream RTP voice data to a voice logger. And so alternatively, the RSP-Z2 gateway can be provisioned to act as a sort of a digital middleman between the voice logger and sources that use completely different transport protocols. And as you can see, we're going from one digital transport protocol method to another digital transport protocol method. There are no LMR 4-wire devices directly connected to the gateway in this example. This is purely a digital interface application as we see here. So as you can see here, the RSP-Z2 is no longer supporting LMR sources, but those channel interfaces have been digitally extended over the network to remote gateways using JPS ROIP protocols. You may be thinking that the RSP-Z2 Dual Channel Gateway is really equivalent to a pair of NXU2A or NXU2B single channel gateways, and in some respects that's true. However, the NXU's primary interface is and can only be a 4-wire interface, meaning those single channel gateways can only support LMR talk groups. So to be clear, NXUs all have 4-wire interfaces that cannot be reprovisioned to support digital interfaces, just like the RSP-Z2. And the NXUs are only capable of delivering communications using JPS ROIP protocol and not RTP. So as you may know, we have discontinued the ARA1 analog radio adapter module, which was a single channel gateway that also had a 4-wire interface, just like the NXU2A or the NXU2B, but it was also able to support RTP and SIP. So the RSP-Z2 in some respects has superseded the single channel ARA1 module and is actually more cost effective and more versatile than the discontinued ARA1 module. And one thing those single channel modules cannot do is establish a back-to-back digital interface or transition from one digital protocol to another digital protocol. So where the RSP-Z2 gateway shines in terms of an independent pass-through configuration is when the JPS bridge channels are implemented in a distributed wide area system architecture. And this is not considered a standalone application, as the Z2 controller will be needed to manage the system. You can check out our previous webcast where we talked about distributed wide area systems that incorporated multiple RSP-Z2 gateways in the presence of a Z2 controller for larger system management. So this is an example of our user interface of a distributed wide area system that can utilize multiple RSP-Z2s and ACU-Z1 gateways. So this is the main benefit of the Z2 controller. This is the management of many gateways. You can see all free resources at the left and a handful of interoperability domains in the center. These are interoperable nets or domains. And this is what 2 of those resources would look like if they were being supported by an RSP-Z2 gateway in an independent pass-through configuration. But because of the flexibility of the RSP-Z2, we can replace the LMR donor radios with RTP interfaces that can then stream voice communications to separate record channels. And remember, we can create back-to-back digital interfaces. You can see one of our RSP-Z2 gateway RTP interfaces in the free resources panel at the left, upper left, and this represents one of our record channels. We can then move the RTP voice logging channel to the existing interoperability net, and any communications involving any of the resources within that net will be archived by the logging recorder. So let's take a brief look at the backend services that support the archiving and reviewing of voice communications. Remember, this is just a generalized description of services, and your existing logging recorder functions may be a bit different. And as you know, one of our preferred transport protocols used in voice logging applications is unicast RTP. And because RTP is a standards-based protocol, many manufacturers of voice logging applications also incorporate RTP. This makes our hardware very compatible with many existing systems as well as dispatch platforms as well. So RTP is really a good interface for third-party devices. And so as you can see in the diagram, all we need to do is point the voice data from the RTP interface on the RSP-Z2 gateway to a designated record port on the voice logging server. And in this example, that would be port 9006. After the interface is designated as an RTP interface, all we need to do is enter the IP address and the port value of the designated record port on the logging recorder server or the appliance. So depending on the manufacturer of the voice logging platform, you will need to designate a specific record port for the matching port of the destination. Again, in this case, it's 9006 in this example. And so this tells the record port to expect a unicast stream from the RSP-Z2 gateway backhaul interface. And that's all there is to streaming RTP communications from an RSP-Z2 at the right to a voice logger at the left. It's pretty simple. And of course, you can review the archived voice communications. And unlike analog magnetic tape, digital voice logging can sometimes include metadata, and everything is searchable with respect to time and date. And again, if your agency or customer already has a voice logging platform, JPS gateways that implement SIP or RTP can easily be integrated into those existing systems. And naturally, JPS also has a voice logging offering that will be integrated directly into our larger wide area systems. And so, as you know, many of our JPS offerings have RTP capabilities such as the ACU-2000, the ACU-T, and even the ACU-5000. And like the JPS Dual Channel Gateway and the ACU-Z1 modular gateway, all are capable of streaming RTP voice communications to a voice logging system, or really for that matter, any communication appliance that uses SIP or RTP as a standard-based protocol can interface with our gateways, and this includes consoles. So I'd like to thank all of you for joining our webcast today, and if you need more information regarding the logging of voice communications using our products and voice logging solutions that we do offer, you can always call us directly or visit our website at jpsinterop.com. And Carol, do you have something you'd like to close with?
Yes, I want to invite everyone to join us at the virtual IWCE at the end of August. Please look forward to seeing each of you as soon as we can get through with all this nightmare where we're unable to travel at this time. But in the meantime, we are available. You have our contact information. Contact Iggy or I, either one. Thank you so much.
So once again, thank you, everybody, and hopefully we'll see you on our next webcast. Appreciate it, everybody.